Hello everyone. Today we are going to learn some control system MCQs from EAC previous year questions. Okay, let's get started. First question: the unit impulse response of a second order system is 1 by 6 e power minus 0.8 t sin 6.6 t, and the natural frequency and the damping ratio of the systems are. What they given was the impulse response of the second order system. What they asked, natural frequency and damping ratio, that is omega n and del. Okay, how is going to be done means, let's see the impulse response. It is like e power minus et sin at. Some formula for this equation is there. What is that was s divided by s plus a the whole square plus a squared, right? So just substitute these values. So here what is a is 0.6 and a is 0.8, s plus a is 0.8, b is 0.6. So b divided by s plus a the whole square plus b square. Okay, then 1 by 6 part is previously we are put this value. These are already given in the impulse equation. Then simplify these equations and we get one second order characteristic equation. Then find omega n squared. From there we can find del value. Okay, first definitely you have to know the equation of e power minus at sin bt. What is that was b divided by s plus a the whole square plus b square. Okay, next question: the unity feedback control system with forward path transfer function g of s equal to k divided by s plus 5. What is the error transfer function used for the determination of error coefficient? Okay, we have to find the error transfer function. How are you going to find? It's a little bit unique question from the other questions. Okay, so one question is asked in ESC question. Let's see the answer. There is a formula for transfer function of error coefficient. What is that was error coefficient of s of s divided by r of s equal to r of s minus cfs divided by r of s. Cfs is output, r of s is input. So error transfer function is equal to 1 minus cfs divided by r of s. What they given was only g of s. Okay, we know how to form cfs by r of s equation. Then form the equation by cfs r of s and completely minus it from 1, and then we can find the answer. Okay, it is s plus 5 divided by s plus 5 plus k. Okay, error transfer function equal to 1 minus cfs by r of s. We find cfs by r of s is a transfer function. Also it is g of s divided by 1 plus g of s h of s is the transfer function of cfs by r of s. That is mean it's a transfer function. Then minus 1 minus the transfer function is called error transfer function. Okay, just remember that it is a little bit different question from others. Okay, the next one: consider the function f of s equal to omega equal to s squared plus omega squared. F of s is the Laplace transform of f of t. The final value of f of t will be, okay, just look into the equation. It is similar like a sin t equation, right? If it is s by s squared plus omega squared, it is cos t. Omega divided by s squared plus omega squared is equal to sin t. Okay, so it's a Laplace transform. Then we convert it into f of t, means it is sin t. Okay, so what's the value between f of t is equal to minus 1 to plus 1. How it is so? If we put 0 in sin 0, then it is 0, and sin 90 means 1, and sin pi means it is minus 1. Then the circle is repeated. Okay, the value is between minus 1 to plus 1 for sin t. So the answer D is the correct one. And the next one: the system has the following transfer function: g of s equal to 1 by s square plus 0.1 s plus 1. If step input is applied to the system, then the settling time within 5% tolerance band will be. Okay, it's a very simple question, but what's the trick here was, most of us remember the 2% tolerance band formula. What is that? 4 divided by omega n del, but 5% tolerance band equation will be 3 divided by omega n del. Okay, so it's in a second order system. G of s equal to s square plus 0.1 s plus 1. It is similar like second order characteristic equation. So from this we can find del and omega n. It is very easy. After that, it is they are required to find 5% tolerance band. So 3 by omega n del. Substitute this equation, get the answer. If it is 2%, means it is 4 by omega n del. Okay. The next question: the working of PMMC, permanent magnet moving coil meter, is described by a second order differential equation: J d square theta by dt square plus d theta by dt plus s theta equal to t. okay, what they given was mechanical systems. Okay, mechanical system transfer function. Then we convert into second order system, just like the characteristic equation of second order system. Then find the what they asked was, assuming d equal to 0, the undamped natural angular frequency. Undamped natural angular frequency is omega n. Okay, how we find omega n? So second order characteristic equation will be s square plus 2 del omega n s plus omega n squared. Okay, just stand this equation and modify this equation into that characteristic form and then find the omega n answer. Okay, so what they given was j d square dt by dt square, just like that. Then converted into the transfer function means just theta s will be in left hand side and take out all the coefficients in the right side to be down of the denominator of the transfer function. Then we got the answer like this. But the transfer function characteristic will start with s squared, so just divided, take j out. So the s squared will be there and plus d by j plus s by j. Okay, so the term is like similar like second order characteristic equation. Then substitute omega n squared equal to s by j, then omega n equal to root of s by j. Okay, just turn this characteristic coefficient equation into second order characteristic equation, then only you can find the correct answer here. Okay, what's the right answer here was a, root of s by j. Okay, the next one, a sensor requires 30 seconds to indicate 90% of the response to the step input. The sensor is a first order system. The time constant is, or they given was log 0.1 equal to minus 2.3. So in this question log will be definitely there. Okay, in this type of AE level questions, only GATE they give calculator, but this type of question there's no calculator, so they give the log value itself. Okay, what they given was a sensor requires 30 seconds to indicate 90% of the response of the step input. Okay, then first write the step input response. What is that? C of s by R of s equal to 1 by 1 plus st. Okay, if C of s only means take s of R of s that side, so take the complementary function and then we reduce the equation into 1 minus e power minus t by t. It is in the time domain. Okay, so step response is 90%, so they put 0.9 equal to 1 minus e power minus, in t they put 30 seconds. Okay, then simplify this term. How will you simplify? Take one this side, so 0.1 is the answer. If you cut out log e, then take log of e power, sorry, log of 0.1 equal to minus 30 by 5. Okay, then tau, sorry, from this equation we can find the tau. Okay, to cut out e you have to take log on each side. So this side log, left side log will be, sorry, e will be cut out, this side log 0.1 will be there, log 0.1 will be they are already given. By this we can find the answer. Okay, tau equal to 13 seconds is the answer. Okay, it's a little bit different from other questions, so that I take the question. So what the answer? 13 second B. Okay, next one, for a critically damped system the closed loop poles are, okay, it's very easy but sometimes we forget the answer. Okay, critical damped system is del equal to 1, then the reals are equal, real and negative. Okay, so the option B is the right answer, equal, real and negative. What about others? If the del is equal to 0 to 1 means underdamped means the poles are complex conjugate. Okay, if it is greater than 1, overdamped means the poles are real, unequal and negative. If it is del equal to 0, undamped means the poles are imaginary. Okay, just remember all these questions from this one question. Okay, just remember all. Okay, okay friends, that's all about today. If you have any doubt in this question, please write it in the comment below. Thank you so much for your valuable time. Thank you.